anything? Anything? Nothing? Everything is clear? Okay. We're looking at chapter 6, and we would like to accomplish, if we can, 6.1 through 6.3 tonight. If you remember something that you want to ask, please stop me. So, all trig functions, 6 trig functions, have 6 inverse trig functions. Okay, and you can say, as I mentioned last time, how is it possible? What are you talking about? Well, this is what I'm talking about. If I want to graph sine x, I will graph this, of course, between negative pi over 2 and pi over 2. So this is sine x. You can say no, and I will agree, it's not. So I'm going to finally graph sine x and continue forever, and continue forever. And you will say, what are you talking about? There is no trig function for something like this, because by the horizontal line test, this is not one-to-one. But as I mentioned a few minutes ago, we truncate the domain. We assume, which is incorrect, but we will say, well, we're going to define this function only between negative pi over 2 and pi over 2, because it takes all its values, all possible values, and this piece is one-to-one. So it doesn't mean that we're going to disregard this. We have ways of determining the rest and whatever we need, okay? But for now, we're going to say the domain of this function, sine, is defined only on negative pi over 2, pi over 2. You'll see what happens with the rest. And taking its values, what is the range of sine? Range of sine. We all know range of sine. Look at the graph and you'll identify the range of sine.
1 to negative 1 to 1.
Excellent. Now, thank you so much. Because sine is now a one-to-one function, arc sine is my preference, or sine inverse, same thing, is defined on negative 1, 1, and taken values on negative pi over 2, pi over 2. Here's how I would like you to remember this situation. Like this. On the unit circle, everything that happens for sine is between negative pi over 2 and pi over 2. This is negative pi over 2, and this is pi over 2, and everything in between. Okay, what am I saying here? And I'm looking at the handout, or I don't have an example here with sine, so let's find an example with sine. I'm going to share my screen. Here it is. Find the exact value of each expression. So we're going to choose from here. For now, just sine, because that's all we discussed, only sine. Use a calculator, that's easy as well. And then we're going to look at some situations with sine in a minute. So let's go back. Just plain sine. No, I didn't mean to click twice, sorry. Okay, so let's choose from here something with sine. Either 15 or 17 or 21 or 24. Let's choose. Just to illustrate what we just talked about. Okay, I'm going to start with 17. In 17, we are asked to find sine inverse of -1. Let's see, is there anything else in there? Oh, let's also look at 21, both of them. Sine inverse the square root of 2 over 2. Okay. So sine inverse of -1, sine inverse of -1, it's acceptable because it's applied to a number between -1 and 1. I'll come back here. I just want to make a comparison so you understand this. So on page 2, what if I ask you to find sine inverse of 3? What will you say? Sine inverse of 3. What will you say? Anyone, please, just say something. What will you say about sine of 3? Sine inverse of 3, sorry. Please?
That you can.
Excellent. There is no angle whose sine is 3. So this is not possible. So coming back to our example, sine inverse of -1. Well, I know that this is where sine is -1. So this is asking, find the angle whose sine is -1. And I'm going to write -π/2. Why? Because sine -π/2 is -1. Now, can anyone tell us sine inverse of the square root of 2 over 2? So remember, sine is positive here and is negative here. So this angle has to be in the first quadrant. Do we know an angle whose sine is the square root of 2 over 2?
π/4.
Thank you very much. And that's it. Why is this? It's because, look, the square root of 2 over 2 is a number here. And sine π/4 is the square root of 2 over 2. Π/4 is here. This is the easiest way to remember where to look for sine and sine inverse. Okay? Between -π/2 and π/2 and everything in between. Not here. First and fourth. Okay, moving on to cosine. So here's the graph of cosine. So this is cosine x. And you'll say there is no inverse function for something like this. It's not possible because the function is not 1-to-1. I will have to agree. But then I will say, look, what happens now. Is this 1-to-1? Yes. So like before, we will truncate the domain of cosine. So we're going to say that the cosine is defined between 0 and pi, taking values between -1 and 1, like sine, of course, same thing. And of course, arc cosine or cosine inverse is defined on -1-to-1, taking values on 0 pi. The easiest thing to remember for this, similar to sine, is the following. First and second quadrants. So let's see how this works. Let's illustrate. Okay, so let's choose some cosine. Anyone? Anyone would like to choose cosine? One or two examples with cosine. Is
Can we do
anyone?
25.
Which one, Sophie? Sorry?
25.
25 it is. Perfect. Good. So 25 says cosine inverse of negative the square root of 3 over 2. Great job. Okay. So since we are talking about cosine inverse of a negative angle, of a negative number, sorry, I know that the angle has to be in the second quadrant because cosine is negative in the second quadrant. So I have to find an angle whose cosine is negative the square root of 3 over 2. But the angle has to be in the second quadrant, of course, because that's where a cosine is negative. So remember I said, don't bother with anything else but 3 little numbers. And here was the table that I created with you quickly. So here's the table. So pi over 6, pi over 4, pi over 3. Sine, cosine, 1/2, 1/2. I think that the table is too small, it's not clear. I'll write it again, make it again. So here's the table. Sine, cosine, pi over 6, pi over 4, pi over 3. We know the table, but I just want to show it again. 1/2, 1/2. The square root of 3 over 2, the square root of 3 over 2. This is the nicest, the square root of 2 over 2. So I'm looking for the square root of 3 over 2 for cosine. So this is what I'm looking at. But this is for pi over 6. Pi over 6 is here. So the reference angle has to be pi over 6. Since this is pi, I go back pi over 6. Pi minus pi over 6. 6 minus 1, 5 pi over 6. So the answer is 5 pi over 6. Let me know if I need to redo this or explain it again. Any questions on this problem? Is this clear? Yes, no?
Yeah, it's clear to me.
Okay, so quickly I just wanted to show also with the graphing calculator so you know what to expect. So if you want to check, make sure that the mode is in radian mode. So how will you check this? So I want to check that cosine inverse, which is this this function in blue with a second feature. And I put negative the square root of, where is my square root? Square root of 3, outside, careful, outside divided by 2. And when I click enter, I have to get 5 pi over 6, but the calculator will not give me 5 pi over 6. So I have to create the 5 pi over 6. And when I click enter, I have to get this 2 points, If I don't, something is wrong. And I have to go back to the drawing board. Okay, any questions on this? Okay, so finally, let's talk about tangent. Here's the graph of tangent. And you're going to say, rightfully so, this is not a one-to-one function. What are you talking about? Why are you even mentioning the inverse function? Well, like before, we are going to truncate the domain. This time we have to say the tangent is defined on open interval, open because of vertical asymptotes, negative pi over 2, pi over 2, and negative infinity to infinity. The range is anything. Nice, because arctangent or tangent inverse is defined here and takes values on negative pi over 2, pi over 2. I want to graph. Notice that I didn't emphasize a lot. I mean, I didn't graph sine inverse or cosine inverse, but I need to graph arctangent. So all we have to do with arctangent, I'm not going to graph them on the same coordinate system, but we have tangent here. All I have to do with tangent is this, to graph the arctangent. Of course, it's not the correct direction. In a moment, I'll graph it. It's this. But this is the idea. Okay, so here's the graph of arctangent. It has horizontal asymptotes at pi over 2 and negative pi over 2. So this is 1. Y equals pi over 2. Y equals negative pi over 2. And here's the graph of arctangent. So this is arc tangent x. Okay, so yes, if you graph the other one will be this. So let me just so you know how it looks like. So it will have vertical asymptotes, and the graph will be something like this. Symmetric, of course, with respect to the line y equals x. Okay, so this is a very important function in calculus. So again, this was tangent. The inverse of this function is this. It kind of looks like the cube root, but it's not the cube root. The cube root does not have horizontal asymptotes. Okay, so this is the arctangent x. Okay, the easiest thing to remember, like before, let me see where I'm with the time. Okay, 17, that's good. I think I'm on page 4, yeah. The easiest thing to remember is this. I'm super emphasizing it. So this is for arc tangent x.
Can you put that last page on top?
Yes, of course. So what I wanted you to understand is it's the same with sine. That's why I put these full points here, because this one has empty points because of the vertical asymptotes of the tangent function. Okay, so the same with sine, but open here and here. Okay, so let's choose an example with arctangent and then move on. Okay, would you like to choose anything with arctangent or tangent inverse? Arctangent or tangent inverse? Anyone, please?
23.
You said 23. Very good. Let's take a look. Tangent inverse of the square root of 3. Very good. Okay. Every time you encounter something like this, always take 20 seconds to build this. So you have it in front of you. If you memorize the entire table, the long page, that's fine too. It's up to you. But all you have to do is remember this. And since it's the square root of 3, it can only be this over this. Sorry, it can only be this over this. We're talking about tangent. Sine over cosine. Only this over this. When you divide this number by this number, you get the square root of 3. When you divide this number by this number, you have 1 over the square root of 3 and you have to rationalize it. So if it's the square root of 3, it must be this divided by this. That's the only way I can get the square root of 3. So the angle is pi over 3. So the answer is pi over 3. Why? Because tangent pi over 3 is the square root of 3. How is this? Any questions? Any
Can
questions?
you explain that last part? You said the tangent of the
Yes,
pi over 3 is what?
yes,
Sorry?
yes. So tangent is sine over cosine. The square root of 3 over 2 times 2 over 1, I simplify and I get the square root of 3. But this over this will be 1 over the square root of 3, which is the square root of 3 over 3, after I rationalize it. So tangent of pi over 3, sine over cosine, and I get the square root of 3. Tangent pi over 6 is a complicated number. Is this divided by this, and after I flip, I have to rationalize. Is this better?
Yeah, I was more asking, you said, you go to the other page. Yeah, you said that the tangent of pi over 3 equals the square root of 3.
Yes.
So it's just kind of like, okay.
Yes, because this is asking, we have to get used to it. I fully understand it doesn't come easy. We have to think about it. So this is asking us, find the angle whose tangent is the square root of 3. So tangent inverse of the square root of 3 means find the angle whose tangent is the square root of 3. And I found it. Because tangent pi over 3 is the square root of 3.
Okay, that makes a lot more sense now. Thank you.
Yes, I that's why we have to go through all these. Let me change my